Hello and welcome to Project 152, your weekly specialist exam prep. Now, every week we go through past questions from the QCAA. If you stick with us for the whole time, you'll have done every single one of the 152 questions that they've ever released. Now, this week is week 25 and we're going tech active here, so fire up your calculator. Let's get started. So first question here, and we've got some simple harmonic motion and acceleration with respect to displacement here, and we're being asked to determine the period of the motion in seconds. Now this is a relatively straightforward question as long as you remember that you have a formula sheet right here, simple harmonic motion. Now the formula that we're given here is acceleration equals negative 2.95x, and a formula that looks exactly like that is right here. Acceleration equals negative gamma squared x. So what do we know? We know that negative 2.95x is equal to negative gamma squared x. So 2.95 is equal to gamma squared. So of course, if 2.95 is equal to gamma squared, relatively easy to find 2.95. It's just the square root of this, and we'll know what gamma is. And we get a gamma of about 1.7175. Now, why would we want to know what gamma is? Because look down here further, we have t. T stands for period for some reason. T is equal to 2 pi over gamma, and the period is what we want to know. So when I type that into my calculator, 2 pi over 1.7175, I get 3.658, etc. And can I see a period of 3.658? Yes, I see 3.66, which is certainly close enough. There's our answer. Simple harmonic motion. These formulas are awesome. Learn them, do them, celebrate. Next question. So here's a fun little question because your calculator will do the whole thing for you. We're told f of x equals inverse tan 2x, and we're trying to determine f dash of 3. So we're putting 3 into the derivative of this function. Let's do it, calculator. So here's my calculator, and I'm going to go math, and I'm going to put the derivative in there. So the derivative of shift tan and 2x is what we want, so x there. And what is x equal to? We're going to sub x equals 3 into there. We're going to execute that, and we're going to get 0.054, 0.05. Can I see that here? Yes, I can. The answer is A. Thank you very much. Straightforward question. Great what you can do with your calculator. Celebrate. Next question. So a fun little question here. We've got two forces, one straight down and one diagonally down, acting on a single object. Now it says determine the magnitude of the resultant force acting on the object. In other words, if we add these two vectors together, we will know what the resultant force is. So let's just label up these two vectors, vector u and vector v. Now vector u, really straightforward, don't have to do any calculations here because I can see that it's got going 0 in the I direction, so I'll write 0i, not strictly necessary. But then it's going 12 down, so negative 12j. So that's V. That's U. Now V, little more work to do because we've got it in polar form. We've got a magnitude of 10 and an angle of negative 22 because the angle is going downwards, right? So negative 22. So we should be able to convert that really fast. 10 cos the angle, negative 22 degrees, in the I direction, plus 10 sine negative 22 degrees in the J direction. So this is a formula you should just know how to convert from component form to polar form like that. Now, not strictly necessary, but I am going to convert these to decimals just so you can see exactly what pops out. All right, so V is 9.27I and negative 3.746J. You can see, you can check this sort of drawing here with a 22-degree angle like that. We'd expect it to be going quite a bit this direction, so positive 9.27, and then downwards by a little bit, negative 3.7. That feels about right. Okay, the resultant force is going to be the two vectors added together, so U plus V as a single vector. Now, 0i plus 9.27i, very easy. Let's do that without a calculator. A negative 12 minus 3.746. I think I can do that without a calculator as well. negative 15.746J. Okay, this is the resultant force, and you can see that none of the answers match. Why? Because we weren't asked for the resultant force, we were asked for the magnitude of the resultant force. So to find the magnitude, we're using Pythagoras' theorem, 9.27 squared plus negative 15.746 squared. Type that into your calculator and let's hope we see an answer. Now the answer I get is 18.27 newtons. It's a force. Have we got an answer there? Yes, we do. The answer is D. Good one. Celebrate. So a pretty big looking question here, 3 parts, but there's actually very little working involved here. Let's just focus on part A for now and get started. So it says an article claims that the mean starting salary of graduates in Australia is currently 64,800. So that's the population mean. So population mean is equal to 64,800. And it also says it has a standard deviation for the population of 4,500. Okay, to check the validity, we're going to do a sample size of 360 people. Determine the probability that the sample mean starting salary will be between 64,000 and 65,000. So, we're doing a normal distribution here. Now, because we're doing sample means, we've got to be a little bit careful. Now, the mean of the sample means will be equal to the mean of the population. So it is going to be 64,800. But what is different is the standard deviation. Now that standard deviation, I have a formula for that. Hello formula. It's equal to sigma over root n. Alright, so let's just get rid of that, do it again. The standard deviation of our sample means is going to be equal to sigma 45,000 over root n over root 360. Type that into your calculator and I get 237.17. That is my sample standard deviation. Now what I'm trying to find is the probability that the sample mean will be between 64,000 and 65,000. Alright, so I'm trying to find the probability that that happens. That the sample mean is between 64,000 and 65,000. Calculator. Now I'm in stat mode here and I'm going to go to distribute. I'm going to go to normal distribution and NCD. I'm trying to find that probability there. Alright, now just be careful, make sure you take your time. The lower value is going to be 64,000. The upper value is going to be 65,000. Now that is going to be 237.17. Don't look at the label and think it's going to be 4,500. We actually need this new standard deviation that we calculated. So that's going to be 237.17. And then this number is going to be the same. It's going to be 64,800. What I like to do is scroll down, draw it so that I know that this picture looks the same as my picture, right? 65,000, 64,000, and I get a probability of 0.80000. Very, very nice. The probability is 0.8. And I guess I should put a 0 on the end to show that I'm really trying to be accurate here. That's my answer to that question. Straightforward. I can celebrate. Now for that next part, I don't need this working, so I've got rid of it. From the data, the agent calculates a confidence interval between these two values. Determine the sample mean. Alright, this is an easy question. It's 1 mark. We just need to come up with the answer. When you are calculating your confidence interval, right, the sample mean sits right here, and either side of it are your lower and upper bounds, right? So to calculate the sample mean from these two values, I can just add them together and divide by 2. That will give me the middle value, give me the average if you like, which is right between these two numbers. That's it. It's a 1 mark question, so you get a mark for the answer 65,200. Add them together, divided by 2. Super simple. Small glitch, but we'll carry on. We've got part C here. Comment on the reasonableness of the article's claim based on the confidence interval. So there's our confidence interval, 64,589 to 65,811. Now the article's claim was that the population mean is 64,800. And you can see 64,800 is indeed within this confidence interval. And so we can take that information and turn it into a statement that will earn us 2 marks. So what's the statement? Something like this. Mu lies within the confidence interval, right? The population mean lies within that confidence interval. Therefore, the website's claim is reasonable. 2 mark question. You're saying that mu lies within the confidence interval, and then you're saying that the website's claim is reasonable. 2 marks. Celebrate. Done. All right, so a classic question here. We're using Simpson's rule to evaluate the reasonableness of something that someone said. Now, I'm going to draw a very quick picture of what this looks like. It's some kind of river with the width of 12 meters and various depths along the way. All right, that's what it looks like. Now, when we're right at the start of the river, it's about 0.52 depth. And then it's got a maximum depth of like 4.27 at the 6 meters, and then it comes back down again. So this is a Simpson's rule question. We're not given the actual function, but we don't actually need a function to solve a Simpson's rule question. So here is Simpson's rule right here. This one I find a little bit hard to read, so I prefer like a simplified version of Simpson's rule, and so I'm going to use that to solve this. So the area is equal to the width of each strip divided by 3. Now the width of each strip here is 2, 2, 2, 2, 2. So 2 over 3 here. So that's my first step. And now the sum of the ends. Now the ends here are 0.52 and 0.59. Just shifting down to here to have some more space. Now plus 4 times the sum of the odds. Now, what do we mean by the odds here? Well, this is the end or the start, and that's actually the 0th point, right? Now, this is the first one, this is the second one, this is the third one, this is the fourth one, this is the fifth one, and this is the 6th one. So, the odds are 2.15, 4.27, and 1.28. People get confused. They think the first one is odd. The first one is 0. It's the second one here that we're interested in as an odd. And finally, we have 2 times the evens. So 2 times, and the evens, 0 doesn't count, 6 doesn't count because they're the ends. So the evens are 3.7 and 3.32. Now, when you type that all carefully into your calculator, you get an area of 30.63. Is it like meters? Yes, it's meters squared. All right, so what do we do with that information? Use Simpson's rule to evaluate the reasonableness of this estimation. So they estimated that the area was 15 meters squared, but Simpson's rule tells me that the area is 30.63. So what do I say? Here's a little statement. Let's move forward. There we go. The estimate of the area is less than half of the value obtained using Simpson's rule, so it is not reasonable. So a nice little Simpson's rule question there. Be aware that these questions can be asked where you're not given any kind of function, but you are given a bunch of points. Maybe draw yourself a little picture so you understand it, and then be very, very careful with your calculation and justify your thought process. Celebrate. So this is a fun little question because when I look at this question, I don't know how I'm going to get to the end, but I can see where I should start. I've got a matrix and I've got this equation. The matrix to the power of 4 equals P times the matrix to the power of 3 plus Q to the matrix squared, R times blah, 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 blah. Use matrix algebra to determine the values of P, Q, and R. So I've got a matrix and it just feels like I should put that matrix into this formula. Right, I am going to use my calculator to help me out. So here's my calculator and I enter a matrix into it. So I'm going to press the math button and I'm going to press this one here and a 3 by 3. And I'm just going to enter that matrix in. Okay, so far so good. I've got that matrix in there. And I'm told this equation, given a to the power of 4 equals blah, a to the 3, a to the blah, 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 blah. So I'd like to know what a to the 4 is so I can put it into this equation. So what is a to the 4? All right. So there's a to the 4. That's a really big thing. Now, I pre-prepared some stuff, so I don't have to write all of this down. Let's go with a little bit of animation. There is a to the 4. Okay, so I'm told a to the 4, and there's a to the 4. And I'm going to keep going with my equation here. Now, the next part of the equation is p times a to the 3. So I might just jump up here, just scroll through my matrix really fast, and replace that 4 with a 3. And there I have my next little bit. So I can now put in my next part of my equation equals p times a to the 3. And there's a to the 3. And now I can put in q times a squared. So replacing the 3 with a 2, pressing enter, and there is a squared. So let's put in a squared. All right, and then what do we have? R times a. Well, that's simple. R times a. There's a. Don't need my calculator for that. Boom, there's R times a. And then the last bit says 3 times the identity matrix. Now you should know that this is what the identity matrix is, and 3 times the identity matrix is just 3, 3, 3. So this, in all its glory, is the equation, and I've essentially started the question. Now this is where your sort of mathematical instincts should pop in, and you should go, well, hang on, I've got 3 unknowns. I don't know what P is, I don't know what Q is, and I don't know what R is. 3 unknowns. If I had 3 equations with those unknowns in them, 3 equations, 3 unknowns, I'd be able to solve like a simultaneous equation and come up with an answer. So let's look at what would happen if we put the P into this matrix. We have 37P, 38P, 32P, 32P, 31P, 25P, 38P, 38P, 31P. Everything's got a P next to it. In this one, everything's got a Q next to it. In this one, everything's got an R next to it. And in this one, it's all 3s and 0s. Right. Now let's focus just on the first element of every single one of these. Right, we have 177 equals 37P, 9Q, 1R, or just R, and finally 3. If this is equal to this plus this plus this, we're adding all those elements together to get 177. So we can express that as an equation. Come on. There we go. There's my equation. 177 equals 37P, the first element, 9Q, the second element, R, and 3. I can do the same thing for our second element in every single matrix. So 176 equals 38P, 8Q, 2R, and 0. All right, and then finally, I can do it here. 144 equals 32P, 6Q, 2R, and 0. Now, you might be asking yourself, well, hang on, there's like 9 elements in each of these matrices. Why did you choose the first row here? No reason. I could have picked actually anything. I could have picked 144, 145, 120 and made 3 equations using the second row. I could have also made 3 equations using the third row. It doesn't matter as long as I end up with 3 equations and 3 variables. Now, I'm just going to rewrite these. You can get the hint from these arrows here, just to make them a little more matrix algebra friendly. All right, 37P, blah, 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 and blah, blah, blah. All right, so just rewriting it, so we've got P, Q, R, and a constant. P, Q, R, and a constant. P, Q, R, and a constant. And you might be looking at this thinking, this is a job for Gaussian elimination. And unfortunately, Gaussian elimination would be a good move here, but it definitely says use matrix algebra. Gaussian elimination is not matrix algebra. So instead of putting it into an augmented matrix, we can put this into a different kind of matrix algebra setup. All right, so here we have 37, 9, and 1, P, Q, and R, and then our answers, 174, 176, and 144. This is a great way to express these 3 equations in a matrix equation. Okay, so now that we have a matrix equation, we can use matrix algebra to solve it. Because this equation boils down to A times X equals B, And using matrix algebra, we can say that AX inverse A, so we're using pre-multiplication here. That's going to give me my index, and then I'm going to end up here. So we can rewrite this equation as just X, which is P, Q, and R, is equal to the inverse of this matrix times this. And here is one I prepared earlier. PQR equals the inverse of this times 174, 176, 144. Now, I can do this entirely on my calculator. So from here, I'm going to enter some matrices. First, I need a 3 by 3, and I'll just enter this 3 by 3 matrix in there. All right, that's entered in there. Don't forget, we're finding the inverse of it. So we're just going to do it to the power of -1 there. And then we're going to multiply it by, and then what do I have? Another matrix, 174, 176, and 144. So that, where's my mouse gone? Here, 3 by 1. And I'm just entering those 3 values in. So fingers crossed, if I've entered this all correctly, I go over to my calculator, press execute, and I get 2, 10, 10. And that is going to be our answer. So PQR equals 2, 10, 10. Use matrix algebra, this was matrix algebra, to determine the values of P, Q, and R, 2, 10, and 10. Love this question because each step you can have a think about it and move on to the next step. Nothing too tricky about it. Celebrate. So a very intimidating question here, just scary to read it. Consider the polynomial this and this, where a and b are real numbers. Given that this polynomial divided by this polynomial has a remainder of a minus bi, evaluate the reasonableness that this is a factor of pz. Okay, scary, no idea where to start, but what I do see is this mention of a remainder. And so I'm immediately thinking, hang on, this feels like the remainder theorem. I see you saying the word remainder, and I see like a z minus 2i. Great. Now, if you don't remember what the remainder theorem is, it is this. When we divide a polynomial f of x by x minus c, the remainder is f of c. Now, with regards to this question, when we divide a polynomial p of z by q of z, which in this case is z minus 2i, the remainder is p of 2i. The remainder is p of 2i. And it says that the remainder is a minus bi. So, let's put that all together. When we divide a polynomial by one another, right, the remainder, which is a minus bi, will be equal to f of c, p of 2i. So we get this p of 2i equals a minus bi. Now, what is p of 2i? Well, we just sub 2i into this whole equation here, and we'll know what p of 2i is. Okay, so I've subbed in 2i into p of z. Now, I've just swapped that around, so say a minus bi is equal to, and here's p of 2i. Now, I can simplify all of this. Now, this first bit is 2 to the 3, which is 8, but I to the 3 is negative I, so we get negative 8i here. Now this next bit, 2i squared, you've got to square the 2 to make 4, but then I squared is negative 1. So 4 times negative 1 is negative 4. Got to be super careful with these ones. So we've got negative 2bi times 2i. So the 2 times 2 makes 4. So now I have negative, let's write it here, negative 4bi, but then I'm multiplying by another I. So this I times I makes negative 1. So this becomes negative 1. Negative 4b times negative 1 makes positive 4b. And finally, I've got this 3i on the end. I can go further. Now, the first term isn't interesting, doesn't change at all, but this bit, I times negative 4 makes negative 4i, and negative a times negative 4 makes positive 4a. And then the last bits, they don't change much at all either. Okay, now, what am I doing? So many times you run into these questions, it all boils down to equating coefficients on either side. So if I just see I've got I, I've got I, I've got I can group those into a single thing. It makes negative 9i, right? And that is my imaginary component there. And then my real components are 4a and 4b. How do I know these are real? Because I was told here that a and b are real. So 4 times a real number, 4 times a real number. So I get 4a plus 4b here. Now don't forget, this whole thing started because we found out that all of this was equal to a minus bi. All right, this is beautiful because this is like a common sort of thing that happens in these complex number style questions where you have to equate the real components with and equate the imaginary components. So I'm going to get essentially two equations here. I'm going to get a equals 4a plus 4b, and I'm going to get negative bi equals negative 9i. Actually, that's, oh wow, that's really simple, right? If negative bi equals negative 9i, therefore b equals 9. Okay, so I know b equals 9. Now the other equation I had here is a equals 4a plus 4b, but I just figured out that b is equal to 9. So subbing in 9 for b, I get a equals 4a plus 36. And that means if I move this a to here, I get 3a equals negative 36. So a equals negative 12. Hallelujah, I know what a and b are. Now, is that useful to me? I don't know, but I feel like I can sub it in here and something will happen. Okay, so pz, I've written it here, pz equals z cubed plus I minus 12. I'm substituting negative 12 in here for a, right? There's where that negative 12 comes from. And then b, negative 2biz, we see a b there, so I'm putting that 9 in there. I think I can simplify this just by doing some basic maths. Now that is pz. That's great, I know what pz is now. Now, I haven't answered the question though, that wasn't the question. What was the question? Evaluate the reasonableness that z minus a minus bi is a factor of pz. Okay, wait. If something is a factor of pz, then the thing, so if z minus a minus bi is a factor, then that means that a minus bi, if I put it into pz, it's going to be equal to 0, right? That's the factor theorem. So the factor theorem says that if we put a minus bi into p, it's going to be equal to 0. But hang on, a minus bi is not a minus bi. I know what a and b are. A is negative 12 and b is 9. So let's replace a and b with those things. All right, so I've put a little like question mark 0 here. That's to say that if I put negative 12 minus 9i in here and it is equal to 0, then the claim that this is a factor is true. If I put it in and it's not equal to 0, then the claim that this is a factor is false. So nothing left to do but to put this in to p of z. Now I can do all of that with my calculator, so I am going to do it with my calculator. So I'll just show you how I've done that, just so you can see it. If I go into my math mode here and I click complex, I can start entering the I values in there. And that's really all I need to do to be able to do this. So pz is equal to z cubed. So z is negative 12 minus 9i. And I'm cubing that. And then I'm entering bracket I plus 12. And I'm multiplying that by the same thing. 9i squared. Be careful. Negative 9i squared. And then what else? Negative 18 times I times negative 12, negative 9i. And I think I'm nearly done. Plus 3i. Now let's press enter on that, moment of truth. And we get this enormous thing. All right, so let's write it down. P of negative 12 minus 9i doesn't equal 0, it equals 1566 minus 285i. All right, so what are we supposed to do with this information, because it's a bit of an anticlimax? Well, believe it or not, it's actually fantastic news for us, and it is the end of the question, because we can finish this off now with a reasonableness statement that looks like this. Since p, negative 12 minus 9i, does not equal 0, it is not reasonable that z minus a minus bi is a factor of pz. The only way we'd be able to say that it was reasonable if this was in fact equal to 0. So absolutely any other value being spat out means that it's not reasonable. All right, a great, complex, unfamiliar question, and a reminder to just make a start and then just see what happens as you move forward through these sorts of questions. Celebrate! So that is it, the end of another Project 152. That's week 25. Next week is week 26, and we are truly closing in on finishing this whole thing up. Catch you next week.